Well, welcome everybody to the last day of the Refrigeration 101 and 201. I hope you've enjoyed it. To this afternoon or this morning, we're going to work with wiring, like wiring defrost clocks and charging the system, and you know, a few things to look at there. So let's just get to it here. In an overview of the defrost itself, air defrost, since you're in a cooler, the air is 35 degrees, and if you keep the fans running, they blow on the ice and they melt the ice off the coil and everything's fine. If you need to, you can use a time clock and you'd be time initiated and time terminated because you know, you don't have any heaters that are working in that type of a coil. Electric defrost is time initiated and temperature terminated, and they have a fail-safe time. In other words, how the longest it would allow it to go through defrost. You don't want it to just sit in there and heat up the box. So that's you know, the two types we're going to talk about today: air defrost and electric defrost. And let's get down to it here. Okay. As far as electric defrost is concerned, an overview of what goes on is, you know, basically the system running, the thermostat's calling, it's closed, the solenoid valve is open, and refrigeration's going on in a low temp application. And, you know, you've got your heaters de-energized, of course, because you don't want those running at the same time as your refrigeration. Then when the time clock initiates it, you have a defrost initiation, and you'll open up the circuit to the room thermostat and liquid line solenoid valve, and that closes the solenoid valve, and you go to a pump down. And then the heaters come on, and that melts the ice off the coils, and it terminates by temperature or time. If you've got a temperature termination, then when it gets up to a certain temperature, normally around 55 degrees, it's going to shut off those heaters and go back into the cooling mode if necessary, if the clock or the thermostat is still calling. And then you've got recovery. You know, with the thermostat circuit energized, your system will start, but the fan delay is going to keep that the fans from turning and blowing the water off the coils and making ponds in the middle of a frozen box. So you got to watch out for that. So as far as defrosts are concerned, how many times do we want to do that a day? Well, normally a couple times a day. You know, very rarely does one suffice, but you know, you want to do it a minimum amount of times, and you want to do that you know, when you're not busy, like in the middle of the night. You don't want to do it when you're loading product in there, that kind of thing. Let's see. And then you've got the adjustment for the actual termination itself. You know, you want that to get all of the ice off the coil, but you don't want to have heat on that water long enough to create steam. Steam's a problem. It comes out and rolls up to the ceiling of the walk-in box and creates stalactites and you know, basically you have ice on the roof or the ceiling of the box. So the fan delay is there to make sure that the coil refreezes before the fans come on. So refrigeration starts to happen, but the fans aren't running. It's taking the coil and getting it colder than freezing and for long enough to refreeze whatever water's left on there and then bring the fans back on. Oh, come on. Yeah, I'm locked up here, Julie.
Let's see.
I don't know what's going on here.
You just take your laser pointer off. You switch over to just your and just click now or hit your space bar.
Okay, got it. It's
there you go.
Straightened up. I wonder what it's all about. Yeah, weird.
I think
okay,
you know, WebEx has had a tremendous number of problems this morning. I think they're just overloaded.
Oh, I wouldn't doubt it. You know, we'll probably get somebody else's presentation running here pretty quick. All right. So as far as the time clocks are concerned, there's a couple different models, a couple different brands that are, you know, mostly out there. There's a lot of different brands, but Paragon seems to be one of the top brands, and Grassland. And so when you look at these things, you know, it's a mechanical clock, electrically operated, has a dial pin for an initiation time. The fail-safe trip pointer is basically it's pointing at that center clock, and the time pointer itself that tells you what time you're setting it for. In this case, it's dark 6 o'clock in the evening. The setting knob, you turn that to set the actual clock itself. The 2-hour dial is the maximum amount of defrost time you would be able to get, and 24-hour dial is initiation. So, you know, that's all of the things that you really need to do with it. Now, as far as a Grassland timer is concerned, it has pretty much the same function. You've got tripper pins. If they're in, it's the cooling cycle. If they're out, it means it's the defrost. So you can set the defrost at 15-minute intervals or 15 minutes pieces at a time. An indicator for AM or PM. Time indicator is just a clock face, hour and minute hands. And setting the thing is pretty much rotate it to the clockwise until you get to the proper time on your indication light, indication arrow. And then you've got indicator lights that tell you whether you're in the freezing mode or whether you're in the defrost mode. Termination is accomplished with a couple different ideas here. You've got a fixed snap disc that appear like this. A fixed snap disc is like a 5709L bone. That's the one that I know of, but it's a defrost termination and fan delay. And then you've got the F25107 or similar type deal for the adjustable model. It's mounted in the cooler. It's temperature termination, and the fan delay is set to that temperature termination. So when you look at the terminals, on the clock, you're bringing your line voltage into in and 1. That's your line voltage coming in here and here. And then that keeps your timer motor running, so the clock keeps time. And then you've got down at the on the rest of this thing, you've got terminal 2 that's tied together with a jumper bar, and you know, basically 2 to 4 is closed for refrigeration. It's when everything's working, the fans, liquid line solenoid, and thermostat are all on that circuit. And then 3 is your defrost heaters. So you notice that they're all the same terminals as one another. There's 1 and in, and 3 and 4 and X. And if you look at the Grassland, you have the same thing. You got 1 and in, and 3 and 4 and X that are used for the defrost. So they're used exactly the same. So when you look at the actual wiring diagram of a air defrost type time initiated, time terminated defrost clock, you're going to bring your power into in and 1 to keep the timer motor running, and then you're going to have closed from 1 to 2 to 4. That's closed, and that brings your power out through your room thermostat, through your liquid line solenoid valve, and back to in. So that's a complete electrical circuit. When it goes into defrost, it switches from this normally closed switch here and closes this normally open one and goes from 1 to 3. It doesn't have any heaters to operate. It's just in essence, shutting things off. It goes into a pump down because number 4 has your liquid line solenoid valve on it. So the liquid line solenoid valve is going to close because it's not energized anymore, and the compressor is going to continue to run until the low pressure switch shuts it off. Now, when you're looking at electric defrost has a lot more wires. You'd consider that this is most likely on the outdoor unit right here, and this is going to be on the indoor unit here. And it has all of your heaters and fan motors and all the rest of the stuff on it. But what goes on here, again, you've got power coming into N and 1 and completes a circuit down through your evaporator fan relay and all that, back down here through number 4 and back up to N. So that's a complete circuit that's making your evaporator fans come on. That is this contactor right over here. And then this line here, coming off of number 4, comes over to your room thermostat and your liquid line solenoid valve. And that all is a complete circuit when it comes back to N again. So, that's the refrigeration portion of it when 2 to 4 is closed. Now, we initiated defrost. When we initiated defrost, it opens up 2 and it closes 3. Okay? So when it closes that, it's 1 to 3, it hits your defrost heater relay, defrost heater fan contactor, and down here, it comes down this way to a high limit if that's installed on the system. If it's not, it doesn't go down there. And then you're, in essence, just going to a defrost heater relay or contactor over here where you're energizing those heaters down in this area. So, that's the defrost going on. And then what happens when it terminates is the X terminal here hits a solenoid to 3, and that's coming back from your defrost termination and fan delay. So that's coming back and telling it, okay, well, we got warm enough. Let's just go ahead and hit X. X energizes that coil, and it releases the switch to go the other direction. When it does that, then this is remaining in the fan off mode. Okay, it's waiting until it gets down to 32 degrees or below, so it can reclose, and it closes 2 to 3, and refrigeration is happening. So that's what goes on. Now, 3-phase is exactly the same. When you're just looking at defrost heater relays over here that are 3-pole that come down here to H1, 2, and 3, F1, 2, and 3 because they're 3-phase fan motors, and additional heaters if there's other ones as well. The actual routing of everything is the same. X comes up here. X energizes that solenoid to terminate your defrost, and then you wait for your coil to get cold enough and the fans close and your evaporator fan motors turn on. So very simple. Just takes a second of looking at it, and it comes right out. Okay, so the recovery cycle is in essence just that. You're recovering from the defrost. The defrost, you are using heaters, and when this termination switch gets up to 55 degrees, it switches and allows the refrigeration to start back up if necessary. And if it does, then it delays the fans coming on until it gets down to someplace around 25 to 33 degrees. So troubleshooting defrost, there are some issues that you might have with defrost as far as banding, that kind of thing. But a lot of times that's due to distribution of the refrigerant going into the coil and not necessarily the defrost heater locations. But you want to set your defrost time if you're going to have a time type situation to about 1/3 greater than the longest time to totally defrost the coil. The defrost terminator is best to be adjustable. I like the adjustable feature because that keeps you from having steam on the roof and causing those ice to build up on the roof. Yeah, you should always terminate on temperature, as that's also your fan delay. So, you don't want to terminate your defrost prematurely, because if your fans don't shut off, then you're going to blow water off the coil. So what it's basically saying is, don't click past the defrost, or terminate the defrost until it hits that fan delay. So, if you need to, if you've got multiple coils, you can use a holding relay to keep the thing from coming back in. You can defrost multiple unit coolers in the same space, no problem, with one holding relay, and those would bring that terminator back to X after all of them energized. Okay, so that's kind of what it looks like when the steam hits the ceiling. So when we're field wiring, you got to double check all your wiring connections. Make sure everything is tight. So many times you get loose wires just in shipment. The wires can get loose. So on a unit, you go through, you check your contactor, you check anywhere that you've got electrical connections, and make sure that they're tight. Electrical characteristics. You've got single phase or three phase. You got multiple voltages that you could have, and so the characteristics of the unit, you've got to check the nameplate and make sure it is correct for what you've got going on the job before the crane hauls it to the roof. That can be expensive. Use copper conductors. Don't use aluminum. Aluminum tends to loosen up over time, and make sure that the unit's grounded, and now with system startup, as far as trying to get the system to go, the first thing you're going to do is you're going to check for leaks after you've done your brazing and everything else. You'll pressurize the system to 150 pounds and use trace refrigerant or trace gas for your leak detector to pick up, so you can go around and sniff the whole system. 150 is a key number, because that's the maximum you'd want to expose, like the bottom plate on a 4D or 6D compressor. If you go over that, there's a possibility of actually blowing the gasket out of that area, because it's only supposed to hold suction pressure. And so if you've got a semi-hermetic compressor and the codes ask for higher pressures than 150, you should always valve off that compressor and let the rest of the system be leak checked at the higher pressure. So you got to watch out for what the local codes say. So what do you need? You're going to need to evacuate the system. You need to get the air out of the system, get it ready to put refrigerant into. So you're going to need a vacuum pump and a micron gauge, and you're going to need some refrigerant. So we recommend that you go 3 times, evacuate 3 times to 500 microns, see if it holds. And if it doesn't hold, then you might want to repressurize again and try and find where that leak is. Sometimes it's contaminants or moisture that's boiling off that creates higher pressure or makes your microns rise. And it might take a long time to do if you have a lot of contaminants or a leak. So starting her up. Refrigerant charging, you've got subcooling is necessary for expansion valve type systems. In both cases with expansion valves, you're looking at subcooling. In cap tube systems or fixed orifices, you're going to use superheat if necessary. In a lot of cases, they're actually tell you what the poundage is. So when you're charging with refrigerant, you draw that vacuum and you break the vacuum with the refrigerant into the receiver. and you should weigh in about 90% or that 90% charge on that receiver, and then you're going to have to top off the charge a little bit later on, if possible. If the system is a close coupled system and you already know what the parameters are, you can weigh in the amount of refrigerant that you need. Cap tube charging is not that difficult. Basically, it's a fixed ambient, a fixed load. It's consistent. There's no receiver. It's critically charged. You just put in enough refrigerant until the superheat shows up, and you've got enough refrigerant. If you, in most cases on cap tube systems, they have a weight or the actual ounces that are necessary for the closed system like that, and you're going to be just going to that poundage or weight on the charge. If you happen to have changed the condensing unit or changed the compressor to a different model of compressor or different manufacturer of compressor, let's say, for instance, you had one manufacturer's compressor in there and you cross-referenced it to a new model, the shell size might be different, or there might be a difference in the amount of area that's in that compressor or that condensing unit. And that has to be compensated for by the amount of liquid refrigerant that you're going to put in the system. So with expansion valve charging, like I said, you're going to go to 90% of your receiver capacity on your first go around, and then add additional amounts for the liquid line run, which is 4.5 to 5 pounds per ton of refrigerating effect. Start it up, see what's going on, see what your subcooling is, watch to see that your side glass gets clear. When you start up a warm box, you're going to have a bubbly side glass anyway. So that has to be given time to come down to temperature to watch what's going on. It's not something you can just throw gas in and leave. With air conditioning systems, you always have to have airflow. Airflow is necessary to make sure that you've got the proper amount of heat rejection in air conditioning. With a fixed orifice, you're going to weigh in the charge, whatever it says in the book, for the airflow that you have and the ambient conditions. And you adjust the superheat per the charging chart. They'll tell you exactly how much superheat you need to have. Normally it's about 6 degrees, something like that. That's what I've seen most commonly, and in a fixed orifice type situation. With the expansion valves, you're going to weigh in the charge as specified and adjust the subcooling. And they tell you how much subcooling they want, and if the superheat's too high and the subcooling is too low, then you add gas, so you have more refrigerant in the condenser, and it subcools it more. So the troubleshooting checklist. When you're talking to a contractor and he's having trouble with the system, you pretty much have to ask him the questions. What's your superheat at the compressor? What's your superheat at the unit cooler, at the evaporator? What's your subcooling? And if you look at the performance curve, they give you amps to volts. Performance charts like this were available for years and years, and these are actually pretty cool. But we've got a much better tool these days. Copeland Mobile is very simple to scan in the model number or serial number of the compressor, go to the performance page on your phone, and it pretty much is going to tell you, when you tell it what your pressure is on the low side and pressure is on the high side and your amp draw, it'll diagnose the darn thing for you. And here's your compressor curve for current. And you can see here that at 45 and 130, which is the conditions for the CRN 50500, 45 and 130, we're looking at hitting this line right here, and that goes right over to 28 amps. That's what you would expect from that system. If it's lower than that, then there might be some issues. If it's higher than that, definitely there's probably some issues. So that's pretty much how you go through the compressor curves. In the old days, And like I say, Copeland Mobile is the best thing running right now. So, and with that, that's my last slide. I really appreciate everybody coming for the past 6 days. It's been good.